Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mass coder this side. In this video we are going to discuss the beautiful question palindrome partitioning, which is problem number 131 on the LEETCODE. What does the problem say? The problem says we have been given a string s and we have to partition s such that every substring of that partition is a palindrome. What is a palindrome? Which reads same when read from left to right and right to left. That is ABA is a palindrome because it will be read same if I read in this direction or in this direction, right? Now I will have to return all the possible palindrome partitioning of S. Now for the given substring, you can see we have been given output as AAB and AAB, right? You can see that these are the only two partitions which are possible such that every substring is a palindrome partitioning, right? Now I want to draw your attention towards this constraint. S length is less than equals to 16 is less than equals to 16. So you can see the upper bound is actually very low, and whenever this is the case, it directly indicates that recursion will take place. Recursion will take place. But don't judge only on the basis of this, right? This is a very key importance of checking the constraint whenever possible, right? Now, otherwise, how can we see that we have used recursion here? Because we have to explore all the cases. We have to explore all the cases. That is the second reason supporting recursion. Now, how will I do that? I have concurred that recursion is a valid component here. How will I do that? So, I have been given string as B. Index is 0, 1, 2. My approach will be consider the partition. See, if partition possible, my approach is partition possible. Do partition, don't do partition. Don't do partition. Right? As we use in the take and not take approach, same. Take partition, don't take partition. So what I'm saying is AAB is starting with a empty data structure. That is nothing is inside it, right? Now, I'm at index 0. I have to explore index 0. I have to explore index 0. Let me mention 0 also here. Now, moving forward, I will see that I am at index 0. I will start from this index only. I will start from 0 and I will start traversing until 2. Now, I will start traversing until 2. That is, I will use a for loop. So, for suppose this is mentioned as start. So, for I will move from start and will go up till end. I will go up till n minus 1, right? What will happen? My string will be s dot sub str from start and I minus start plus 1. That is the length of the substring I want. Start plus 1, right? What will happen? This will give me a as a substring in the first iteration. I will then check, is a palindrome? Yes, a is a palindrome, so push it into the answer. This is my current stack and AAB was my current, right? And index is 1 now, right? Because I have used 0, I will be moving to 1, right? Otherwise, if I can choose not to take the palindrome partitioning also, right? Moving forward, second time this will give me AA. Is AA a palindrome? Yes. So AAB with AA as a first element, and I will be exploring index 2 now, right? Moving forward, 1 and 2. Third iteration will give me AAB, but that is not a palindrome, so I will not take the partition there, right? Moving forward, AAB1. I have to explore index 1. I am standing here. I will see 1. So it will again give me a palindrome. So data system becomes AA, and I have to explore from index 2, right? That is B. Otherwise, AB, not a palindrome, so no possible subcase. AA2, again 2 is a palindrome, so AAB, right? And exploring index 3. Exploring index 3. Moving forward, this one AA2, exploring index 2, so it will be AAB, exploring index 3. This will be my recursion subtree, and at last I can say that this is one of the possible partitions. This is one of the possible partitions. AAB is one of the possible partitions. AA with B is a possible partition, and as you can see, the output is also same. Okay, so this is my approach. What I am doing is I am using the solve function. So let us say I declared a solve function that will take my current, which is a current is a vector of string. Vector of string. Why vector of string? Because I have to store the strings in it. I have to store the partitioning, right? Current is that. I will store S. I will take my answer, which will be my final answer of all the partitions, right? And I will take my index to explode. Now what I will do, if index is equal or greater than equals to s dot size, that is whole string has been explored, then you have to just to do answer dot push back current and return. Otherwise, you will start a loop I which will go from index up until n minus 1. What will it do? String s1 sorry is equals to s dot sub str I index up till I minus index plus 1, that is the length, right? Now if is palindrome, if s1 is palindrome, if s1 is palindrome, push it into the stack. So cur dot push back, what do I push back? I push back s1 and I call for the next one, so solve for I plus 1, so solve for I plus 1. Otherwise, if that is not the case, or if that is the case also, other you can say cur dot pop back, because I have to do the partitioning for if that is not the case also, right? This will be my answer, right? This will give me my perfect answer. Let us try to code it down real fast. Alright guys, so here we are in the coding section. Before starting to code, I would like to request you to please subscribe to my channel because it really motivates me. Moving forward, so our first approach will be to make a vector string to store the correct answers. Vector string to store all the answers. Vector of string to store the current data structure, current. And now starting off. So I will call the solve function for s, answer, current, and index is currently 0. And I will say return answer. Now solve function has to do most of the things. So solve is a void type function of solve and string s, vector of string, vector of vector string and answer. By reference I will send it, but current will not be sent by reference. So vector of string, current, and int index. First case, if index has already surpassed, so s dot size, in that case answer dot push back current and return. Otherwise, for int I equals to, I will make a string, so string, let's say a equals to empty substring, so I equals to index, it will start from index, go up till s dot length I plus plus, right? First add the characters, so a plus equals to s of I. Moving forward, if solve for if palindrome a, if a is my palindrome, in that case cur dot push back a, right? Moving forward, I will say solve for cur, so solve for s, answer, current, but index will be now I plus 1 because I have explored until I, and now cur dot pop back for further iterations, right? And then return, right? Only function we have to implement is palindrome. So bool palindrome, it is palindrome, okay, palindrome, which is taking a string s, right? Now my int pointer will be I equals to 0, j will be pointing at s dot length minus 1, right? While my I is less than equals to j, if si is not equals to sj, in that case, if si is not equals to sj, in that case return false. Otherwise move your pointers, that is I plus plus j minus minus, and iterations run out to be true, return true. Let us try to compile and run it now. Hope it will work fine. It should not give any error. There is an error. What is the error? I have just not spelled push correctly somewhere. It will be push back, not push back. Let us try to compile and run it now. It is running fine. Let us try to submit it as well. I guess it will run fine. It is running fine. So thank you for watching, and we'll meet tomorrow with a new video. Till then, please keep watching, stay tuned, and do not forget to subscribe and like the video. Thank you. Have a nice day.